Hey guys, today I'm going to talk to you about human populations. This is chapter 7 in the book, and we're in unit 5. I'm going to go ahead and record everything at once, so this is going to be a long video, but just pause it whenever you want to stop and come back to it later. Don't feel like you have to sit and watch the whole thing at once. So, in our chapter 7, we're going to talk about the different populations around the world. Um, some things that you guys really need to make sure that you know is you need to know that the world population is around 7.4 billion people. And the top three most populous countries are going to be China, India, and the US. So as you can see, China and India have way more people than the US even, but we are right at number 3. Another thing I'll note is depending on the source that you look at, Mexico and Japan kind of trade places. So some sources say that Mexico is number 10, and some sources say that Japan is number 10, but they're very close. They're right there around 130 million people. If you go to US, or if you go to census.gov, um, it has some really cool information, and you can actually watch the population estimator change as you sit. So that's pretty neat. So scientists disagree on whether or not humans have a carrying capacity. So we're going to talk about that a little bit. Basically, every 5 days, global population is going to increase by more than a million. So we have about 2 million births and 800,000 deaths every 5 days. Um, as population increased, um, population increased when healthcare got better. We came up with different ways to um, take care of cleanliness in areas, and we also came up with different ways to make food or harvest food. So when we did that as humans, our population increased. So what do you guys think? Do you think that there is a carrying capacity for humans? Um, are there limitations on us? So the debate between scientists is some say yes and some say no. So some of the things that determine carrying capacity we looked at in chapter 6, and those are going to be mostly density dependent factors. So things that are going to be resources, or things that could be limited. So food, water, shelter, um, things that affect food sources, affect health, so predation and disease. So some scientists say yes, we definitely have a carrying capacity as humans. Um, and some say that we've already reached our carrying capacity. Thomas Malthus was the first person to, or first scientist to say that um, humans were going to have a carrying capacity. So he looked at overall population growth, which was exponential or is exponential, and he looked at the food supply, which was in linear growth. So this is the graph that we can kind of look at for Thomas Malthus. So he predicted that eventually we would end up having this food deficit, where we wouldn't have enough food to supply the people that we have. So this is the population curve, and this is the food supply. So as you can see, that's why he thought we would be in a food deficit at some point. So some scientists say no. Some scientists say that humans are too smart to have a carrying capacity. So as we come up with new things, we develop new ways to provide food for people with technology and creativity, we kind of stay away from our carrying capacity. So this is the same graph, and it just shows some sort of invention to help with food production. So we create a food surplus instead of a food deficit. So that's why some scientists say we won't reach our carrying capacity. Here is a question. We'll talk about this in class. Factors that derive or that drive human population growth. So we have 4 different things that we're going to talk about, and I'll break those down into some different topics. So changes in population size, fertility, life expectancy, and migration. So the study of human populations is demography. And if you are a demographer, like this cute little guy here, you are somebody who studies demography. So changes in population size and how they're going to impact population growth. If you have inputs and outputs just like any other system. So our inputs are going to be immigration and birth, and our outputs are going to be emigration and deaths. So if you have a positive growth rate, your inputs are greater than your outputs. And if you have a negative growth rate, then your outputs are greater than your inputs. Immigration, which is what we're used to hearing, is people moving into a country, and emigration is the number of people moving out of a country. So later we're going to talk about net migration rate, which is just the number of immigrants minus immigrants in a country per 1,000 people. As we look at population size, we're going to look at CBR, so crude birth rate, and crude death rate, so CBR and CDR. These numbers are going to be per 1,000 individuals, and it's per year. So these things are going to be important in looking at the differences within populations, and they vary based on what stage of growth a population is in. So some of the things that we're going to have to calculate are going to be global population growth rate and national population growth rate. So basically you've got your inputs minus your outputs over 10, or you have your, and this again is going to be inputs minus outputs over 10. So with global population, you don't move out of the earth. So that's why you don't include immigrants and immigrants there. But in a nation, you would include immigrants and immigrants. So this is just a normal problem like you might have on a test. So birth rate is 12, death rate is 9. So you would set that up this way. So you would have 12 minus 9 over 10, and that's going to give you 3%, or 0.3%. With crude birth rates, you have like numbers that are said to be high and numbers that are said to be low. So globally, we're kind of right there hovering above low at 20 as our CBR. So 20 individuals, 20 births per 1,000 individuals. Germany is an older country with a really, really low birth rate. They have a lot of old people that live in Germany. And the US is at 14, so we're kind of low too, but we're higher than Germany. Niger is a country that's in Africa, and it is in the sub-Saharan area, so they have a really, really high birth rate. So they are having really, really, really high growth right now. Doubling time is something that's super important that you know. You must know this equation. They will ask this equation or something about it on the APES exam. So this is just the number of years it takes for a population to double. So it's developed from the exponential growth formula. If you guys want me to, I will show you how you get it. But basically, it's the number of years it takes to double is going to equal 70 divided by the growth rate. And we assume that the growth rate's constant. So the growth rate that we came up with a few minutes ago was 0.3. You would do 70 divided by 0.3, and that's going to take you however long to double. And I can't do that math right now because I don't have a calculator. Yes, I know you're not supposed to use a calculator, but I'm not that smart to do it really fast. Human population should not double again. So our world population is not going to double again. Basically, scientists are saying that we should reach some sort of stable population by 2100, and that should be 6.8 to 10.5. So as you notice, some scientists believe that we're going to lose quite a few people over the course of the next 100 years or so. Fertility. So fertility is a big thing that impacts population growth, obviously. So TFR, total fertility rate, is the number of children on average that each woman in a population is going to have. So this is going to be different per country, and it depends on education, it depends on economics. So remember that this is per woman and not per 1,000 women. So in 2014, the TFR for here in the US was 1.9, so right around 2, and that'll kind of be important later. And then you have something called replacement fertility or replacement level fertility. So this is the fertility or the TFR that is needed to offset the deaths. And this is to make sure that the population stays stable. So typical replacement level fertility should be around 2. And that is so that you can replace the number like the mom and the dad. So that's where the TFR kind of comes from. Stable populations are going to have a TFR that's equal to replacement level fertility. And then they'll also have immigration equaling immigration. If you have a TFR of less than 2.1 and you have no immigrants, then you'll start seeing a population decline. This is the global fertility, just projections over the next few years, or next several years. So as you can see, we're starting to decline, and that's because mainly of education. So in developed countries, you have higher income, higher education, your replacement level is going to be 2. In developing countries, where you have less than $3 per day made for income, your replacement level fertility is going to be higher, so 2.1, and that's just because of lots of different factors. So if you can imagine having an income per family of less than $3 per day, or less than $6 per day, you're going to have a lot of issues. So you're going to have less health care, you're going to have worse working conditions, and this is going to cause mortality in the youth to be a lot higher. So your replacement level will need to be higher to offset the number of children that are dying. So female education and total fertility rate correlate. So the more educated you are, the less women you have. And studies show this everywhere. We'll talk a little bit more about that in a bit. So this is a question about replacement level fertility. Again, we'll talk about these questions in class, so if you want to look at them, pause them, try and come up with an answer, and I really will talk about them this time. Life expectancy is going to be the average number of years that an infant is going to live, and this is per country and per particular year that somebody is born. So in countries that have better health care, typically countries that have a higher resource use, which typically means that you have a higher environmental impact, they're going to have a greater life expectancy. So like in the US, we have a life expectancy of around 78 years. But if you go to a country in Africa, you might have below 50 years as a life expectancy. So these are some numbers down here. It's usually separated out by overall and then men and women. As you can see, women tend to live a little longer than men, and mainly that's because men have jobs that are cause more deaths. So that gap, that is actually starting to lower because women are choosing some of the same jobs that men were always in before. So we could expect the gap between men and women to close eventually. So another acronym that you need to know is IMR, so infant mortality rate, and then you have CMR, which is child mortality rate, and these things go along with life expectancy, and they do depend on, again, education and wealth of a country or a nation. So infant mortality rate is going to be deaths of children under 1 year, and that's per 1,000. And child mortality is going to be under 5 years per 1,000. So these numbers are infant mortality rates for different countries. So globally, we have an infant mortality rate of 41. And as you can see, you have way different in countries that are developed versus not developed. So in the US, we have an infant mortality rate of 5.9. But in Liberia, you have an infant mortality rate of 63. So as you have countries like this versus countries over here that are developed, that average for global is going to be much higher. Socioeconomics plays a huge role in this number. So even in the US, if we break this down between African American, Caucasian, Hispanic, those numbers are going to vary quite a bit based on just things that are available to different people. So healthcare, food, water, sanitation, and pollution, those are all going to be things that impact this infant mortality rate. All right, so aging and disease. So with age, even if you have a high life expectancy, like in the US, we have a really high life expectancy. We might have a higher CDR than other countries just because you have a different number of elderly people. So like in the US, we have a CDR of around 8. In Mexico, you have a CDR of around 5. But we have way more people over 65. So really you have to look at more details than just aging. We'll talk about that a little bit more. Disease is going to be another thing that impacts populations. So the World Health Organization, or WHO, and you do need to know that organization, they have said that now infectious diseases are the second leading causes of death, like after heart disease. So tuberculosis and malaria used to be number 1, but with healthcare and vaccines and things, we have been able to lower the numbers of tuberculosis and malaria. But now we have number 1 is HIV and AIDS. So between 1990 and 2012, AIDS killed 28 million people between the ages of 15 and 49. So a lot of the people that have AIDS in the world are actually in sub-Saharan Africa, and we looked at that in our video that we watched last week. There is a country called Lesotho that is on the southern tip of Africa, and they actually have crazy high numbers of HIV/AIDS there. So they, let me see if I can find my numbers again. 23% of their adults have AIDS or HIV, and their life expectancy actually dropped from 63 to 40 years. So they have tons of things going on there as far as HIV goes. So that's going to impact their population growth quite a bit. So the other thing, the last thing that we're going to talk about that impacts population growth is going to be migration. So as promised, this is the net migration rate. So you have basically immigrants, the difference between immigrants and immigrants per 1,000 people. So you have number of immigrants over number of people in a population. And if you have positive number, you have more immigration, and if you have a negative number, you have more immigration. So this map up here is showing you positives, neutrals, and negatives. So we have in North America, we have a lot of people that are moving in. In Mexico, there are a lot of people that are moving out, so all of the orange is moving out. And then you have several areas of green, which are neutral. Down in this map, we have net migrants for a 5-year period. So this just shows different numbers of areas of people that are moving in. So in the green, you have tons of people moving in. So all of the light greens and the dark greens, those are where immigrants are moving to. And in the other colors, that's where people are moving away from. This is a do the math problem from your textbook. Please be sure you know how to do this. We'll talk about this a little bit in class and practice it. But basically you just have to plug into the net migration equation, and then you're going to figure out how long it'll take to double. And you have all of the information you need there. So age structure diagrams. So this is another big thing, and we'll spend some time on this in class. But age structure diagrams are just going to be a representation of individuals within specific age groups. So each bar, as you can see, is going to represent 5 years. So you go 5, 10, 15, 20. And then all of the bars are going to represent the total population size. So you have 3 different basic types of age structure diagrams. So we have pyramids, columns, and inverted pyramids. So with a pyramid or a population pyramid, that just means that you have more young than you do old. And this is typical of developing countries. So India and Venezuela are going to be some of our examples for that. Population momentum is something that happens typically in developing countries too. So you have this huge group of people that are in their prime as far as fertility goes. So as the countries start to develop, they also increase their education. And with increase of education, we know comes increases in family planning. And as you increase that, your population will start to stabilize. So population momentum is going to be like a continued time of growth after those reduction measures or family planning has been implemented. So in a column type, which is like the US, you have very little difference between 0 and 50 years of age. So it's kind of like a box. Usually you have less numbers as you get up towards the top. So this is going to be slow or very little population growth in these countries. So US, Australia, Sweden, Canada, those are going to be some examples of countries who have a columnar age structure diagram. Then you have your inverted pyramid. The inverted pyramid's kind of weird because I want it to look like a real inverted pyramid, but it doesn't. So it kind of looks like a diamond to me. But basically, the thing that you need to know is that you have way less people in their prime as far as fertility goes than you do older folks. So as you can see, you have way more people above 50 in these countries, so like in Germany. So Germany, Russia, China is even starting to see this pattern, and you can look at an age structure diagram for China to see that. And then you also have Italy. So these countries are typically older countries with lots of education. They have lots of money. They have lots of old people. And their TFR is usually below 2.1, so they don't need that many to replace people. And then the population is shrinking. So you have, these are in your textbooks. You have India, which is your pyramid. You have United States, which is your columnar. And then you have Germany, which is your inverted pyramid. And you can see that China is starting to get this look over here. Here is a cute little question for you. We'll talk about this in class. And now we're going to move on to the demographic transition model. So the theory of demographic transition is just as countries move through their growth, well, basically as countries move from being really poor to being sustainable on their own, they go through predictable shifts in population. And we're going to look at those now. We can look at age structure diagrams in correlation to those as well. So phase 1 is pre-industrial. You have really slow population growth here because you have really high birth rates and really high death rates. So they're almost equal. And you can go back and look at this here. So you have almost equal birth rates and death rates. You have typically a subsistence economy, which is non-monetary. So you have to have hunting, gathering, farming for basic needs. Medical care is usually really, really bad, if any. You have horrible sanitation. really, really hard to find clean water. All of these things are going to cause these types of countries to have high infant mortality rate, and you really have zero population growth right now. Um, Lesotho, which I mentioned earlier, because of the number of cases of AIDS, has actually moved back to this stage, as several other countries in Africa have. So their CDR is 28 and their CBR is 26, so almost equal. But most countries have moved out of phase one. And here is Lesotho. This age structure diagram is the pyramid type. So for phase one, you have your pyramid. This is actually for Uganda and not Lesotho. But this is the type of work or economy you would expect to see there. So in phase two, this is transitional, so you have lots of population growth, and I'll scoot back to our demographic transition. So as you can see, the death rate's going to decline, and the birth rate is still way higher. So that's why you end up with rapid population growth, because you have high birth rates but low death rates. And this is because you have added sanitation, you've added health care, you have more access to clean water, and greater access to food. So India is a country that is in phase two. And population's not balanced here. So again, you have more births than deaths. Let me make sure that I didn't forget something there. Oh, you do have reduced infant mortality right here, and that again is because of healthcare and education. Stage three or phase three is industrial. This is where we are and where Canada is based on the four-phase model. So we have a stable population, we have great economy, great educational system, so that means that you're going to have fewer people. So affluence is going to be just a term to describe countries or areas that have plentiful wealth, and they describe wealth as money, but also as belongings too. And again, you're going to have a columnar type or a column type age structure diagram. In stage four, you're going to have countries like that have your inverted pyramid. So that's going to be countries like Germany, Russia, Italy. They're going to have a declining population growth because of they have developed such great economy, such great education systems that women wait to have kids, or they don't have kids at all, so they have a declining population or negative growth. And depending on the country, governments may seek immigrants. So like they may advertise that people can come live there for cheaper if they're coming from another country. This is our demographic transition model, so we'll look at it again. So we have our phase one, where we have really high birth rates and really high death rates. Then you have your phase two. So as you add education and your economy starts to get better, you're going to have more health care, better access to food. Your death rates are going to decline, but your birth rates are still going to stay high. As you get to the third phase, your birth rates are going to decline because of family planning and such. And then once you get to your fourth phase, birth rates and death rates are low. So your population is going to start declining. Here is a question, and I will get my face off of it so that you can read it. Be sure to pause. One more. I'm just going to move myself around a lot. Okay. Traveling faces of Miss Wright. So with family planning, and we'll talk about this a good bit in class too, it's just the regulation of spacing or numbers through the use of birth control. So basically it's just going to offer people a choice. So do you want to have kids, two kids in the same year? Do you want to have 50 kids or two kids? And this has to do with education. As you look at these bars, you're looking at women with no education versus having a high school education. So typically, people who have no education versus education are going to have way different in TFR. So in Ethiopia, for example, you have 6.1 TFR for people who didn't go to school versus 2 that went to school. And you can see these same trends as you go through all of these countries. Kenya and Thailand are going to be 2 countries who did family planning campaigns. So they had really high population numbers, so the government started promoting lower population numbers. So they advertised condom use and birth control, and they showed the risks of overpopulating. These are going to be some of the types of ads that you would see. So men who care plan their families. And this is another ad down here. And I'll show you guys some small videos in class. The goal of family planning is usually not to limit the number of births, but to educate families on how to be able to support them, the family at its best. Okay, so this is kind of cool, but this is one family that decided that they wanted to have 1 kid. So typically, trends show that the number of offspring one family has, it will carry through generations. So if the 1-child family continue to have 1 child through 4 generations, they would end up with 3 extra people. And then the 2-child family would produce 14 people if each pair had 2 children. And then in a 3-child family, if that continued through 4 generations, that ends up being 39 people. So you can see how population growth can take off based on the number of kids per generation. More questions? Let me move my face again. Okay, so population size, economic development, and consumption. Those are all going to be things that are going to influence the environment, which is why we're here. So resources are usually used in higher quantities in developed countries. So like we use way more stuff than we need to versus Africa. So 6 billion people live in developing countries versus 1.2 billion people living in developed countries. But this 1.2 billion, way outused compared to the 6 billion. And we'll look at that as we go. So the ecological footprint in different countries is insane. And when you see ours, it makes me kind of sad. So world average is 2.7 hectares per capita, and per capita, just so you know, means per person. So in the US, the average ecological footprint is 9 hectares per capita. And if you do your hectare math, so 9 times 2.2, that's going to give you lots of acres per person. In China, you have 1.8. So basically, we are way less of a population than China, but we use the same amount of resources that they do. Kind of crazy. This is the breakdown of some of the other countries, and then global average is here. So all of us that are overusing are way overusing. And you guys could go back and recalculate your ecological footprint if you don't remember, just to kind of see where you stand. The IPAT equation is super important as well. So with the IPAT equation, we're looking at impact, which equals population, times affluence times technology. So basically what this says is that the impact is the overall economic or environmental effect from these things. So population, of course, is kind of straightforward. So 2 people are going to use more things than 1. 5 people are going to use more than 2. Affluent, so if you are living in a more affluential area, so higher wealth area is going to use more. And technology you have to be really careful with, because technology really is just destructive technology. So not all technology is going to impact the environment negatively. So the wealth gap. So this is kind of what I was talking about before. So if you live in a developed nation, you typically live in a larger house, you spend more money. We are consuming way more, 80 times more than the poorest nations. So this is like way back in the day, because I'm pretty certain that y'all haven't seen one of these boats, but I had one at my house. But this is a typical normal thing that you would see in the US, and this is what you would see in Egypt, and it's still the same today. So impact of affluence. We're going to look at, start looking at our economics now, and we'll look at more economics later. But GDP is going to be gross domestic product. So this is the value of all products and services produced in a country per year. So it is made up of these things, and this is super important. So consumer spending, investments, government spending, and exports minus imports. So things going out minus things coming in. So GDP is going to correlate with pollution levels. So low GDP equals low pollution, high GDP equals high pollution. And as GDP increases, pollution's going to, oh, hold on, let me get this point. So as you grow in a country, your GDP typically increases. Once it increases past a certain point, so once a country is fairly wealthy, then pollution levels might start to decrease because that country spends more money on environmental protection. So this is kind of an important thing as you look at those application type questions. So high GDP equals high pollution, but as you get to a certain point of wealth, you might start spending some of that money to help prevent bad things from happening as far as harming the environment goes. Let me make sure that I'm good with that one. Okay, so local versus global versus urban. So local impacts are usually things that happen in rural societies. So there are things like overuse of land, overuse of biomass. So for example, in Brazil, you guys know that there's a huge deforestation problem going on. So people that live in Brazil are only thinking about Brazil, which is fine because we're humans and that's what we do. But locally, it's causing erosion, soil degradation, and habitat loss. And those things are pretty bad, but so that's leading to issues there. But in bigger picture, it's also causing global issues. So globally, the deforestation in Brazil is leading to reduced CO2 uptake by plants, which means that you have less cellular respiration going on, less photosynthesis going on, and increased fertilizer use. So we are making more fertilizer to fertilize the soil that we have degraded, which is increasing greenhouse gases. So local stuff is going to impact global stuff. With urban, urban is defined as having more than 1,000 people per square mile, or same thing, 385 people per kilometer. People in urban areas tend to have a smaller ecological footprint, and this is just because they usually have access to public transport or services close by. So think about any big cities that you've traveled to. Most people live in a smaller place. They have less waste just because of where they live. They ride, like in Atlanta, you would ride MARTA instead of driving your car. Or if you lived in New York City, you would ride the subway or walk wherever you need to go. So you have less of an ecological footprint. But less affluent urban societies, they still have no access to water, sanitation, or solid waste. Or solid waste disposal. So they they have way less of an ecological footprint, if anything. But look at the conditions that they live in. So there's a toss up there. So the United Nations, this organization, Unhabitat, they estimate that there are 1 billion people living in settlements like this. And we don't want people to live in settlements like this. So squatter settlements have really poor conditions. So our goal is to figure out how we can do all of the things that we want to gain wealth gain education, but also be able to live sustainably. This is just the prediction of people living in urban areas, which I have no interest to live in an urban area. Keep me in the country, guys. These are some of the most populated urban areas in the world. We have New York City and LA on this. So sustainability is going to be the goal. So all goes back to chapter 1. So with sustainable development, we want to be able to improve everyone's standard of living without going and causing environmental harm or more environmental harm. So remember, sustainability, you want to leave, everything as we had it before. So these are some things that we're going to look at, like as a country, as a world, as we move forward. So if populations continue to grow, if people continue to consume, the ecosystem sustainabilities are going to be threatened. So we're going to harm what we need to keep so that we can live. If we continue altering ecosystems, we're going to cause more poverty instead of actually increasing wealth. And then establishing sustainable practices. You guys know lots of ways that we can improve sustainability, and lots of you have great ideas. So the goal is to improve those practices so that we can improve standards of living for all. Here are the last questions. And I know this was fast, but I hope that it helped. We'll talk about some stuff in class, and I hope you guys have a great rest of your weekend.